This is a 2016 AP Calculus free response question. Number 1 says water is pumped into a tank at rate modeled by W of t equals 2000 e to the negative t squared divided by 20 liters per hour from time 0 to 8, where t is measured in hours. Water is removed from the tank at a rate modeled by R of t liters per hour, where R is differentiable and decreasing from 0 to 8. Selected values of R of t are shown in the table above. At time equals to 0, there are 50,000 liters in the tank. 50,000 liters of water in the tank. It's important for you guys to remember this throughout the problem. A is asking for R prime of 2. Estimate R prime of 2. R of t is given by the table above. So R prime of 2, the only way we can do it is by doing the slope formula. So R prime of 2 is going to be 950 minus 1190 over 3 minus 1. Sorry. When you subtract and divide by 2, you should get negative 120. Looking at the table, notice that R of t is in liters per hour. So R prime would be liters per hour squared. The score for this, the points, 1 point for the estimate and 1 point for the units. Okay, B. Use a left Riemann sum with 4 subintervals indicated by the table to estimate the total amount of water removed. Again, remember that this table represents how much water was removed. If I want 4 subintervals, I would go from 0 to 1, 0 to 1, 1 to 3, 3 to 6, and 6 to 8. So the integral from 0 to 8 of R of t dt is going to be delta t times the y value of the x, the left x value. So from 0 to 1, delta t is 1 times 1340. From 1 to 3, delta t is 2 times 1190. From 3 to 6, delta t is 3 times 950. And from 6 to 8, delta t is 2 times 740. When you multiply and add those values, you should get 8,050. And because R of t is liters per hour, that's a velocity problem, you go and you're integrating, then you're finding the amount of water, which would be liters. The second part of that question says, is this an overestimate or an underestimate of the total amount of water removed? Give a reason for your answer. If you look back at whether you look at the table or back at the problem, it does say that R of t is a decreasing function. So if you graph just graph a decreasing function, kind of like an exponential decay, and you do a left Riemann sum, you will see that it's an overestimate. And so you would put this is an overestimate because R of t is a decreasing function. Okay? Okay, so the points for this problem, total of 3. It's going to be 1 point for the left Riemann sum, 1 point for the estimate, the 8,050, and 1 point for your explanation on it being an overestimate. C says use your answer from part B to find an estimate of the total amount of water in the tank. So this is an inside, in and out type of problem. You need to figure out how much water went in, how much water was removed. Keep in mind that there was already 50,000 liters of water in the tank. So this is your initial. Minus how much was removed from part B, which was 8,050. That's how much was removed. But now we got to figure out how much was added, how much was pumped in. And I do have an equation for the rate of the water being pumped in, which is W of T, which we'll have to integrate from 0 to 8. Remember that this is a calculator problem, so that makes our life a lot easier. When you integrate W of T from 0 to 8, you should get 7,836.19. Calculating that, you get 49,786 rounded to the nearest whole liters of water. The points for that is a total of 2 points. 1 point for the integral of W of T, 1 point for the estimate, the 49,786. And last, part D. D says for time less than or equal to 8, greater than or equal to 0, is there a time t when the rate at which water is pumped into the tank is the same as the rate at which water is being removed? Well, remember that W of T does represent a rate, and R of T also represents a rate. So we want to see when they are equal to each other. Now, because they give you an interval, 0 to 8, this should be a clue that you're going to use, and they're kind of vague. They don't want you to find the time when they're equal. They're just asking you, is there a time? So these are clues that you're going to use the intermediate value theorem. Again, because they give you a interval from 0 to 8, and they're just asking you, is there a time when they're equal to each other? So what you're going to do is find when this rate, so if I subtract R of T from W of T, I will get W of T minus R of T equals 0. So when I plug in T equals to 0, W of 0 minus R of 0, so W of 0 is 2,000. R of 0, looking back at the table, is 1340 right here. When I subtract, I get 660 at time equals to 0. Now at time equals to 8, W of 8 minus R of 8, W of 8 is 8152 minus 700 will give you negative 618.47. And remember, we're trying to find a time where W of T minus R of T is 0 by the intermediate value theorem. So by the IVT, intermediate value theorem, since W of T minus R of T, which is 0, is between W of 8 minus R of 8 and W of 0 minus R of 0, there is a time t, there is a time t between 8 and 0 such that W of t will equal R of t. Okay, so here's the score for that. So here, this is saying right here that at 0 it's going to be 660, and then at 8 it's going to be negative 618. And by the intermediate value theorem, since 0 falls in between those two, there is a time t at which the rate of the water being pumped in is equal to the rate being removed. And that's going to be 2 points. 1 point for subtracting the rates and 1 point for your explanation. You have to say the intermediate value theorem. Okay, so that's the end of number 1, AP Calculus 2016 free response.